I'll briefly review the ideas, and then after that, I will take specific questions from you. So when there is a problem for you to solve, uh, so uh, so there is a real world problem. So what is the story here? There is a real world problem for you to solve. Real world problem, and you need to map this real world problem into a form, into a model, uh, on which you can uh, do the necessary processing. Like for example, like in one of initially when we started the course, we started with this problem. Let's say we want to find the roots of a polynomial equation, of a quadratic equation, ax square plus bx plus c. We want to find the roots of this, of a quadratic equation. So when we want to find the roots of a quadrant, this is the problem that is given to us. So what is the first question that we need to ask here? What's the first question we need to ask here? How to represent the data? How do you represent this polynomial? How do you represent this polynomial? It's it's the question. The first question that we ask is, how do we represent the polynomial ax square plus bx plus c? So we know that we can, in order to represent this polynomial, we can represent this polynomial by just by storing the coefficients of different terms. The three coefficients. C is the constant term, and A is the coefficient of the quadratic term, and B is the coefficient of the degree 1 term. So we can represent this polynomial as A, B, and by storing these three coefficients. So what's the next question that we need to ask? Let's say in order to represent this polynomial, so we need to store the coefficients A, B, C. What is the next question we need to ask? So the next question we need to ask, important, very important question. Discriminant is a 0.
The value of x to be plugged in.
Value of x to be plugged in. Huh? Not really. What is the data type for these variables? For this, you want to store them, right? So what is the data type? Do you want to store them in integer data types, or float data type, or double data type? So that is the next question you want to ask. Okay, so integer or int. So again, when you think of int, so like there are multiple options. Like let's say if it is an integer, so do you want to use signed int or unsigned int? Do you want to use long int or no short int, or use regular integer? Or if it is so you want to use float, or you want to use double? So you need to decide the appropriate data type for the problem. You need to decide the appropriate data type for the problem. Yes or no? This is the first question. How do you represent the problem in your computer? That is the first question. What data structure that you use? This is what is used. Have a you will study, you have full course on data structures. So what data structure you use to represent the problem at hand is the first question that we ask. Can you have one more, like for example, let's say if you are working with, no, you are trying to solve systems of linear equations. Do you know what systems of linear equations are? Did you study it? You studied systems of linear equations in plus one, plus two, you studied, right? So how can we represent a system of linear equations? Or let's say even before we go to system of linear equations, let's say instead of, in this particular case, we want to, no, in this particular case, what we are trying to do is we are just using, we can store ABC in three, no, in three variables, float ABC. But let's say if you are working on a different problem where we are, before we go to systems of linear equations, I want to take a slightly different problem where the problem is we want to write a program to evaluate a polynomial at a given position. So sigma AI, xi, no, not xi, sigma AI x power I is equal to 0 to n. So this is your polynomial or function x. So how do you represent this polynomial function in an arbitrary degree polynomial function? We need a representative. The problem is, in this problem, we are not trying to find the roots of this polynomial f of x, but we are trying to find we want to write a program to evaluate the polynomial at a given point. Like for example, at a point, at some point, uh, let's say you want to compute f of 2.3 or f of 10.4, something like this. Do we need a 2D array or a 1D array to store this polynomial? We just need a 1D array. And so maybe let's say it can be a float or double. So let's say we use float a of 100, let's say. Would this be sufficient to represent the polynomial, or do we need something else, an extra information? We need to know the degree of the polynomial also. So maybe we may have one more variable in which we store degree. So we can store the degree of the polynomial in some variable. Let's say if the degree is equal to 4, then no, like from a of 4 to a of 0, the coefficients of the polynomial, you can store from a of 0 to a of 4, and a of 5, a of 6, so on and so forth, they contain some garbage value. They don't have any valid values. And you know that they don't have any valid values because you store the degree of the polynomial in this variable. Are you all with me here? So choosing the appropriate data structure, choosing the appropriate representation of the problem is the first important step you have while solving problems. And so now going to that systems of linear equations, how do, let's say if you take a system of linear equation, so how does an example of a system of linear equation will be something like 2x plus 3y is equal to 4, 5x, no, 5x minus 1y is equal to 8. So this is a system of two linear equations. How can we represent the system of two linear equations? 2D array, like what would be the dimensions of the matrix? So there are two ways. So one way is 2, 5, 3, minus 1, 4, 8. We can represent this. We can concatenate the what on the RHS also and put it in a matrix. It is a 2 by 3 matrix, not 3 by 2. So in general, if you have a system of n equations, you can have a n cross n plus 1, sorry, n cross n plus 1 uh, array to represent your systems of linear equations. So in which case we may have something like you can have a float or double. Let's say we can say double is equal double of matrix of m of n, n plus 1. This could be a way of declaring your 2D array. Are you all with me so far? So if you see in the problems that you have encountered so far, you store data either in scalar variables. So if you can see the classification, you can store the, like for example, scalar variable is any variable like, no, like if you have something like double degree, degree is what is called as a scalar variable, simple scalar variable. Or you can have something like double of m. This is an array. This is an array. You can have 1D array, you can have 2D array, so on and so forth. So the first question you have to ask while solving the problem is, what is the appropriate representation of the representation you need to have? Appropriate representation of the problem at hand. So in the last class, we have studied uh, about strings, right? What is a string? A string is a, so like for example, we can have car name 100. So this is not a, what do I say? This is not a string, it's an array of characters. Car name 100 is not, there is no string data type in C. It's just, we just have an array of characters. But what happens is if in, but the understanding is, let's say, uh, so when you have an array of characters, this is the example that we have seen in the class before. If we have an array of characters with followed by the null symbol, null or this is null symbol or null character, then that constitutes what is called as a string. This is /0. This is what is called as a null character. Then this becomes a string. So when you are working with, let's say if you are dealing with with a single string, then you have something like this. Okay, then you declare an array of characters, and you can see, like name has 100, can hold 100 characters. but messy including the null character, it is 6 characters. So rest of the bytes, they go waste. They go waste. Are you all with me here on this one, on the idea of a string? See, the ideas, what I want you to realize is the core essential basic ideas are extremely simple. If you don't capture that core base idea, then everything looks different and everything looks complex. And this is all you have for strings, nothing more than that. That's all you have there for strings. You don't have anything else for strings apart from this. But let's say you are dealing with students names in a class, then what kind of data structure you would, if it is a single name, you use a 1D array of characters. But if it is a uh, but if you have, you want to store some names of 10 students, 20 students, or some n number of students, then how will, what data structure you use to represent it? So you have to use a 2D array. You have to use a 2D array of characters. So what you can do is you can see, no, so char names, names or name list. So name underscore list. You can have, no, let's say you expect there are some 100 students in the class, and the maximum size of each student name is 30 characters. Then you just have class name list 100 30. So if you see here the data structure, if you see the data structure, so this data structure, if it will have, no, it will have, this is the 0th row, this is the first row, and this is the second row, and this is the third row, so on and so forth. And then in the memory, if you see, and then it has, every row has 30 characters present. So this is the 0th column, this is the first column, right? So this is the second column, so on and so forth. So what happens is, let's say someone's name is no uh, so for the sake of simplicity, I just want to use a name with, can you tell me a name with only 2 characters? Okay, let's say Om. So Om, someone's name is Om. Okay, so then, so what happens is Om followed by, you store uh, the null character. So the rest of the space here, it goes waste. Okay, there are 28, there are only 3 characters or 3 bytes used out of 30 bytes. 27 bytes go waste, but that's okay. We are coming up with a, we have to optimize on this, but this is an initial way, initial structure to store the, you know, to store the list of names. Are you all with me here? Yes or no? And so the next important idea here is, if you see, let's, uh, I want to bring out an important point here. Let's say if you have something like int num is some variable, okay? So, so what happens is, when we declare num as, when we declare that variable num, so in the main memory, so our main memory is an array of bytes, and the size of integer is 4 bytes, and the size of integer is 4 bytes. So somewhere in the memory, 4 bytes of memory is allocated to num. 4 bytes of memory is allocated to num. So let's say the base address is 100. This is 101, 102, 103, 103. So the value, so when we refer to num in an expression, when we say num is equal to num plus 1, the semantics is in the memory location associated with the num, in the memory location associated with num, uh, there is some content, you read that content and add 1 to it and store that back into that same location. That is the semantics of the statement num is equal to num plus 1. And then, so let's say the value that is present in num is some, and then if we have address of num, so when we apply this operand address of num, then what we get is we get 100 because 100 is the base address of the variable num. So we have address of num, we have num, right? Are you all with me here so far? Yes or no? And then let's say if you have if you have something like this, ptr is equal to, ptr is a pointer variable, the type of, maybe somewhere we declare something like int star ptr, that is ptr is a variable which holds the address of integers. And when we say ptr is equal to address of num, when we say that, then what happens is num and so this is what we studied, num and star ptr, what are they? Star is what is called as a dereferencing operator. Num and star ptr, what do we call them? Yeah, they are aliases of each other. Okay, so when we apply the star operator on ptr, so whatever the address that is present in ptr, you go to that location and read the contents of that location. So one more question for you. So when we have char name 100, and what will name contain? What does name contain? What does name contain? Here in this example, what does name contain? So name contains the address of, base address of the array, or in other words, the address of name of 0, because name of 0 is this byte. This is name of 0 is the first byte, right? You can call it as address of name of 0, or you can call it as the base address of the array will be contained in the variable name. Are you all with me there? Are you all with me? Yes or no? So the variable name contains the base address of the array. The variable name contains the base address of the array. So if you see, uh, so now what else we have to say here? Okay. So now if you come to the 2D array here, if you come to the 2D array, uh, so you can look at this 2D array as a stack of 1D arrays. This is one 1D array, this is another 1D array, this is another 1D array, this is another 1D array. So what is the base address of this first 1D array? What is the base address of the first or the 0th 1D array? What is the base address of this? No, no. What is the base address of this 1D array? Yeah. So the base address of this 1D array, so the base address of this 1D array is address of, if I use names of 0, comma 0. This is 0, 0, comma 0th element. What is the base address of this, the first 1D array? Yeah. So address of names of 1, 0. Correct? This is a very important observation because when you want to read a list of names, so you want to, while reading the, you want to read the first name and store it here, and you want, or 0th name and store it here, you want to read the first name and go here, and then you want to read the second name and go here, you want to read the third name and want to store it in this place. So you need to know what is the access mechanism that you have to, to store the string. Between, so this 2D array, what the view that we have here, it gets mapped to 1D array. It gets mapped to a 1D array because at the end of the day, uh, the whole it has to be mapped into a linear array of bytes. This 2D array has to be mapped into a linear array of bytes. So let's say if you have something like this, names of ij. So if names of ij is there, so what happens? So what is the actual address of these names of ij? Can you tell me? What is the address of names of ij? Can you tell me the address of names of ij? The expression for it? What does names contain? Names contain the base address of this 2D array. Names contains the base address. This is the base address of the 2D array. So names contain the base address of the 2D array because this whole 2D array, it gets mapped to this whole 2D array, it gets mapped to a 1D structure because this whole in the memory, so this whole row is stored first, and then after that this row is stored next, and after that this row is stored next, so on and so forth. So that means if you are accessing the ith row, then the number of rows that we have to skip, yeah, the number of, yeah, so Balaram Krishna has got it right. So let's say the dimension of this is n and m, where m is the length of the each row. Then what happens is I star m plus j. And we are assuming the size of each entry is only 1 byte because this is a character array. Like for example, if I is equal to 0 and j is equal to 0, then names contain the base address of this element. If I is equal to 1, then what happens is you skip m bytes. If and then but j is equal to 0, then you skip m bytes, and then what you get is uh, this location, right? Does this make sense to everyone? You're all doing good here? Are you all with me? Any questions you want to ask? I see complete silence. Are you all with me? Anyone have trouble understanding these ideas that we have discussed it so far? Were you able to hear me at least? Okay. So now let's try to write some code and see where we go. So here is, say, this is the program that I guess we looked at last time. I have a question for you here. So for what is the parameter passing mechanism for functions? What do we call the parameter passing mechanism for functions? It is what is called as call by value. So on line number 9, what are the parameters that are being passed to the scanf function? What parameters are being passed to scanf? So we are passing, actually what we are passing here is, so so what happens is when you declare this, when you have this format string percentage, what happens is somewhere in the memory, this percent s, no, this percent s, the ASCII value of percent, the ASCII value of s, followed by a null character. So a string like this will be created, and this string will have a base address, right? Let that base address be 100. That is, percent is present at the location 100, and this is present at 101, and the null character is present at 102. Then to scanf, the first parameter that will be passed is 100. That is the base address of this string. And let's say starting from address 200, name of 0, this is this byte corresponds to name of 0. This is the base address of the array. And this is 201, this is 202. Okay, so on and so forth. So what will be passed as second parameter to scanf? More concretely now, what will be passed as parameter? 200. So now the most important thing is, since scanf knows the address of the memory location, it is able to kind of write into those memory locations whatever the user has typed in on the keyboard. Are you with me here? Are you all with me here? But now let's say I have something like this. If I have something like scanf %d num, okay, so let's say I declare num here. So now let's say, now what will be passed to, let's say whatever, no, let's say num is equal to 30. So what will be passed on line number 15? What will be passed to scanf on line number 15? No, no, I am asking a question. What will be passed to scanf on line number 15? So this is very important because when you look at scanf, so let's say somewhere starting from address 400, this is from address 400. So there is percent present here, there is d is present here, followed by that there is a null character. So this is percent, the format string is stored somewhere in the memory. And then let's say starting at address 500, the num is present. So 500, 501, 502. No, 503. So now what is passed to num? What is passed to scanf here? So what is passed to scanf is, the first is the address of the string %d, that is 400 will be passed here, and then the value of num, which is 30, will be passed here. So when you pass 30, the value of num to scanf doesn't know the address of the memory location associated with num. So it will not be able to, whatever that is given on the keyboard, it will not be able to kind of read it and store it in the memory location associated with num. So for the statement on line number 15, it is not going to work. Yes or no? Are you all with me here? I am touching the most essential basics. I want you guys to get these things right. Okay, otherwise you keep getting into trouble again and again and again. But on the contrary, but on the contrary, if I put ampersand here, then what happens? So instead of passing, then what will be passed as second parameter to scanf? Yeah, instead of 30, 500 will be passed. Once 500 is passed as parameter to scanf, the address of the memory location associated with num is known. So scanf will be able to successfully write into that memory location whatever the value it reads from the screen, from the keyboard. Does this make sense? You understand now the parameter passing mechanism and the role of addresses, memory addresses, place. On the contrary, let's say if you want to do printf, so let's say printf %d num. Is this all right? If we use just num, then it is stored at location 30. So yes, that's a good question. So it tries to store at location 30, but usually know that location 30 could be write protected by operating system or something like that. Because of that, you may get segmentation fault. Scanf doesn't know, like, no, it just got 30, it tries to write it at the location 30, but you may not have the permission to write at the location 30. And because of that, or it could correspond to some other data that you are storing there, and that gets overwritten. So your program logic goes wrong. Either your program logic goes wrong and your program crashes, or you may not have a permission to write there because of some other reasons, systems reasons, or constraints from the operating system, in which case again your program crashes. Like for example, memory location associated with 30 could be some location on the ROM or flash RAM, and you may not have permission to write it. So your program may crash. Does scanf and fgetters have limit of number of characters it can receive? So find out, Abhijit. So check. So Narayana, this is not taking even if a past address. Then there is some problem with your code, Narayana. It cannot be the case. But anyway, so before I take your questions, on line number 20, uh, so what is passed? What will be passed here as first parameter for printf? What will be passed as first parameter for printf? 400. And what will be passed as second parameter here? 30. Is there a problem here for printf? There is no problem because we want to print that value 30 on the screen. We are not reading into the variable. We just want to know the value and we want to print it onto the screen. So Mayank has this question whether using %f for storing name and printing name character by character using a loop or one and the same thing. Yeah, whether you, how you read your string, whether you want to use scanf or whether you want to use fgetters or whether you want to read character by character. There are different ways of reading the string. But internally, what makes a character array as a string is it should be a null character terminated. A string should have the null character at the end. Yeah, most of the time compiler will optimize it. So when the same string literal is used in different places, the compiler will reuse it. So, all right. Are you all with me here so far? Great. What is so now with this as input, so let's see binary search, clear all my drawings. You are unable to, Shreyansh is unable to swap strings in string sort. Okay, great. Let me open folder. Shall we spend 15 more minutes and try to write string sort code, or you want to start it in the next class? What's the plan? What do you want? Okay. But I'll give you few hints here. Um so let's say this is I copied the string sort code. So now you want to, I'll just give you few hints, guys. You can do it by yourself. So first thing is I will give you the easiest way for you. So let's say you have char names underscore list. Okay. So you may want to have max name length. Okay, so this is the, so you want to store your strings, your names in uh, a 2D array of characters. Don't worry about the case, no, it's okay. So if you just treat uppercase and lowercase characters are different. Okay, so max name length. What are the other options you have apart from using ASCII? All I'm saying is, if you have something like, Abhijit, and Abhijit, they are different names, no problem. That's fine. Okay. So don't worry about it, or just for the sake of simplicity, assume that the user gives all the names in lowercase characters. Okay. Assume that the user gives input in all lowercase characters. Okay, so the first question for you is how do you go about reading your array? The first question, the first problem you have to solve is how do you solve this problem? So read array function. So you should be able to read names list. Okay, and then you should be able to do No names. This you need to have a print function, read array, and read names. Let me call it as read names and write names. And then you want to give the here names underscore list. So you read names, you sort them, and you print names. So you have to fix these functions. Read array is read names. You change the signature and whatever you have. No, so these are the challenges that you'll have. And if you look at sort, so if you have to do, how can you do the comparison on line number 23? So that is a question. How do you do this comparison? The second question is, how do you swap two names? That is the next challenge. If you solve these two challenges, then you are done. Are you all with me here? I want to kind of split the problem for you. The first thing that we did, I will list down the things that the first thing that we did. This may not be the best thing, but this is the thing that we are using to represent our names. That is the first choice. The second problem is you should know how to read a list of names, and you should know how to print a list of names. And in between there is a sort. We are doing a selection sort here where we are trying to keep track of min. So here in the case of integers, we know like we can do if a is greater than b, do something. So what is the equivalent of this for when you are doing it for strings? Okay, string equivalent for this comparison operation is what I would like to see. You may want to find out. And the other thing is you want to swap. Let's say you want to swap. This is subproblem 4. Problem 5 is you know how to swap variables a and b. But if it is again, how do you swap no, two names in the list? So these are the 5 problems that you have to solve. The first problem is already solved for you. The rest of the four problems you have to solve for yourselves. Are you all with me here? Does this make sense? Yes, no? Problem 4 and 5 is no, like when we are trying to do selection sort, you try to find the smallest element, right? You want to keep track of min element. And while keeping track of min element, you have a loop in which you check two variables a and b, which are holding integers. But you are comparing two names here. You are not comparing two integers. So what is the thing that you should be doing to compare two strings? Is the first question. The second question is, let's say there is names of 0 is contains Banu, and names of 1 contains Anirudh. So Anirudh should come before Banu and Banu should come after Anirudh. How do you swap the two names? That is problem 5. Okay. I will stop here. So I want all of you to take a shot at this problem, and in the next class we will solve this. Okay. That's all. So, and see you next class. Wednesday evening 6:30 we will have my office hours and we can solve some problems together.